Sorry, got cut off there. I was just here in the code, had changed this. I've actually removed one of these numbers and still got the same result. And if I run this whole set of code, as you saw, I get the white screen come up, then it flips, and then I have this bluey-green hello world. It's bluey-green because this red is set to 0 and blue and green are set to max. And this is the X and Y location, which lit the hello world to be up here. So you can practice changing the color and the location and the string that you're writing. Then what you see happens here is it flips it to that same window. See this window is common across those three functions. Then it uses this command kb waiting for the keyboard, so that it waits for someone to press a key on the keyboard. Wait for a key press before it runs the final command, which is to close all windows. In this case, just that one window that it had flipped. And that's everything. So we can save that as hello world. And we can run the whole thing by typing it in down there now. And so here it comes, hello world, and goes off. So why do we use that kb wait command instead of our other input that we've used before where it asks the user for input? Well, kb wait returns the time if you ask for an output, the number of seconds since you turned on your computer. So you can use that time in relation to another time in your code to find out the exact moment someone presses the button. Next, we're going to modify our code, and we're going to make it so that the background is black and that the text is red. And we're also going to change the font size and also the font type. And so what we'll do here, as you see, is change the font here, and we'll also add these two lines of code into our, let's see when that happens. So here we're going to change the background to black. Here we're going to set the text options. We're going to make the text font in our window equal to Times New Roman. Notice we've had to have opened a screen so that we can use this window command. Now we're going to use this text size command also to make the text a certain size. And then the last thing this asks us to do is to make it red. And so we're going to change this to 255.00. And we'll save our code and we'll write hello world. So now it opens the type toolbox, creates a black background, and writes hello world Times New Roman at 40 points. Next, we're going to start to time some things that are happening in this code and see how long some of these things take. So first, let's see how long it takes to open the window and write text to it. We're going to use this getSex command that I used at the beginning of the lecture, which returns again the second since the computer was turned on. So what we'll do is, right here before it opens the window, we'll say T1 equals getSex. And then everything else is the same, except we'll add in this T2 equals getSex right after the flip command. So now we're timing the time between when the screen starts to open and when it flips to the window. Then we wait for the user to respond, we close everything, and we're going to use these two things to compute and write to our command window, check the time to open and flip. So we're going to take T2 minus T1. T2 is going to happen after T1. Multiply it by 1,000 to get to milliseconds and round it. And we're then going to write that out to the screen. We're going to use this digit formatting of this time to open. and print. So let's save that again, and we'll type down here, hello world. So now it should look the same. We'll press spacebar to end it, but now down here it says it took 2,610 milliseconds just to write all this stuff into the buffer and then flip the buffer. Open a screen and flip to the buffer. It takes a few seconds to open the screen, and we don't have that few seconds in the middle of our experiment. Maybe in our experiment we have reaction times that are 300 milliseconds long. We want to present a stimulus for 20 milliseconds. We don't have 2 seconds to wait. So we need to do all that once at the beginning and keep that buffer open until we're ready. If we have little small changes, we can write to the buffer quickly enough that it won't influence our code. But if we have really big, large stimuli with tons of objects we want to make, we can use other canvases called textures, separate buffers that we can draw ahead of time. If we want to time how long it takes to switch between 2 buffers that we've already created, we could try this and have the code first write hello, and then immediately write and present the word world, and see how long it takes in between. So here's what we're going to change our code to show. We're going to take this section of code here, and we're going to paste it into our code here, in between the flip and the drawing. And we're going to time just this section of our code. Fix a couple things here. We're going to keep the space there. So, what we've done here is have now outputs to our draw text command that give us an X and Y coordinates. We just write the word hello here in red at that location. And when we flip it, we use the second command, which if we go back in our slides, is this don't clear. And when it's 1, it leaves the buffer untouched so we can keep drawing to it. So that's going to allow us to draw more text to buffer. So we're going to draw text to buffer, then flip it to the window. Then we're going to start timing, and then we're going to draw more text to the buffer and flip it to the window again. We won't use that 1 this time. And then we're going to time again. And now this time is going to represent, we're going to take this one out. This new time is going to represent the time it takes just to draw more text to the original buffer and to paste it on and flip it into our new window. Notice how we're going to use this new X and new Y from the original command to indicate where to start when we start writing this command. So let's save this, and we'll take a hello world. Nothing to us seems to have changed, even though to the computer first it writes hello and then it writes world. And in this case, it only took 16 milliseconds to do that. 16 milliseconds is a number that we can get by looking at the settings of our monitor. And we can see that the refresh rate of the monitor is 59 or 60 times a second, 60 hertz. So if we have 1,000 milliseconds and we divide that by 60, we get this number 16. Let's look at 59. And so it took 1 refresh of the monitor. The monitor's refreshing 60 times every second, and it just took 1 of those refreshes to be able to get the new information drawn and flipped to the window again. So between this flip and this flip, there is only 1 refresh of the monitor, and that's what we want. Because then there's no extra time needed to write to the buffer. So the answer is 1 refresh to how long it took between these 2 buffers. the stimuli sync together and everything looks fine. If your answer to this kind of test is ever larger than a refresh, if you're writing so much stuff to the buffer that it takes longer than one refresh, then you want to use textures, which we'll talk about later. So, as we go to time our experiment and set up the timing of our stimuli, we're going to use this command, this slack, as well. And I'll show you what this means, a little trick that we can make sure things get presented when we want. So, you can schedule something to flip in the future, maybe after 500 milliseconds after you present something else. But there's always going to be a little slack time in the schedule because of your operating system doing all the other stuff it's doing. For instance, mine's doing all these things down here. So we want to schedule things ahead of time. We want to take a little bit of time off of when we want to present something so that it will actually present it when we want. So what we'll do is use a little bit of slack. And we're going to use it to, in this example, present world 500 milliseconds exactly after hello. So we'll take this slack command here, and we'll paste it into our code. Here it is at the beginning of the code. We're going to put it right here after we open the window. We're going to say, compute how long of slack to use. And so, if we comment everything for now and just look what the slack is equal to, we'll open a window, get the slack, and close it. So we'll type in here, hello world. It's going to open up a window, get slack, and then close the window. And here we can look at slack is equal to 0.083. And now you can see that slack is actually this get flip interval divided by 2. So slack times 2 is that 16.7 milliseconds that I told you about when we computed it from the refresh rate. Notice this is in seconds. So slack times 2 times 1,000 is in milliseconds, and that's our refresh rate. So we're going to use half of our refresh rate, half of the time it takes the monitor to print from up here to down here. And then when we want something to happen at a precise time, we're going to say that we want it to be at that time minus half of that refresh rate, so that anything it needs to do, it does in that little extra bit of slack. So let's uncomment everything here, and we'll go back here and see that when we present our second flip, now here, when we present the second flip, we want it to happen at a certain time. And that's the third input to flip, is this time we want things to happen. So we'll paste that in here. We want it to be at T1 when the first flip happened. Plus 500 milliseconds minus slack, which we computed up there. And then we'll get T2 again. So let's try this. And again, we're going to paste out the difference between T1 and T2 down here. So I saved it. And then let's type in hello world. So now here comes hello, and then world. And once I press spacebar, I'll be able to look at this output and say it took 500 milliseconds to do so, exactly what we wanted. Let's take away, how long did it take? Well, if we try several times without slack and with slack, we should get a sense of, let's try it without slack. And we'll save it, and we'll see what the effect of that is. Hello world. Hello world. Spacebar. So you can see it took an extra refresh of the monitor before it was able to post world, because it started trying to post it at 500 milliseconds, and because it missed the refresh, it had to wait till the next refresh in order to do that. So I'm going to take this back, add back in the slack, save it, and this video is coming to an end, so I'll see you in the next video.